Okay, today's topic is going to be writing function rules, and your EQ for this lesson is how do I determine what the function rule is if I am given an x value and a y value. Okay, so make sure that that is in your EQ box. Next step, we have your vocabulary, so if you would please put this in your vocabulary box. Again, this is a function, a definition of a function, and this is something you already know. So you're given a set of ordered pairs. Remember your ordered pairs. And let's just say that you had 2, 4, 2, 4, 3, 1. And you would put those in a table or you would graph them to determine if they are a function. So a function is any relation that you have one y value for every x value. And remember, the way we determine that in the table is we look to see if there are any repeaters in the x column, and there are. We have a 2 here and a 2 here. And then we had to make sure that the y value that went with it was the same, and it is, so yes, that is a function. The function rule is that part on the table. Remember when we did function tables? It's the part that goes in here where you substitute your x value. Okay, sorry about that interruption. So again, a function rule is the part that goes in this part of the table right here. And it's basically the part where we substitute our x value in to find the y value. So for example, if I gave you that the input is 10 and that the function rule is x plus 7, then you would do 10 plus 7 and you would get 17. So this right here, the x plus 7, that is the function rule. That tells you what to do in order to get y. And then your other vocabulary is just the f of x symbol, and that's the same as saying y. So really you could see that function rule written f of x is x plus 7, okay? Because that's the same as saying y equals x plus 7. And you know if you plugged in that y, that does equal 10 plus 7, okay? So that's the same as just saying y. That says that, okay? All right, so here is your steps. So if you would just put these in your steps box. Your first step is if you are given a relation, that means that you have a set of ordered pairs that you're given. Let's say like maybe you have like 4 ordered pairs and they give you those pairs. You're going to go ahead and you're going to make your table and you're going to put your x's in one and your y's in the other. And then you're going to determine what happened from here to here to get that y. And then you're going to be able to write your function rules. So really what you're doing, it's almost like you're creating that extra space there. So they're going to give you this value, and they're going to give you this value. So you need to determine what happened in here in order to get from here to here. So let's try a couple out. So here we have this table. And just to make things easier, I'm going to go ahead and make another table that's got the function rule in it. And we went from 1 to 5. And then we went from 2 to 6. And then we went from 3 to 7. And then we went from 4 to 8. Well, I need to figure out, how did I get here? How did I get from 1 to 5? Well, I could have added 4 here. But I need to make sure that if that's what my function rule is, then I need to make sure that it works for all of these. So from 2 to 6, yep, I can add 4 there. From 3 to 7, definitely can add 4 there. And from 4 to 8, I can add 4 there. So what I did was I took x, which was 1, and I added 4 to it to get 5. I took x, which was 2, and I added 4. I took x, which was 3, and I added 4. And I took x, which was 4, and I added 4. So my function rule was my x value plus 4 to get that y. So my function rule is x plus 4. Okay? X plus 4 is the answer. Let's try another one. Again, I'm going to go ahead and draw that table just because it makes it so much easier to see, especially when you're first trying to figure out how to do this. So I've got a 1 that went to a 1, I've got a 3 that went to a 9, a 6 that went to a 36, and I've got a 9 that went to an 81. So I'm going to look at these. Well, no change really happened there, so I'm going to skip that one and go to this one. I could have added 6, so I can try 6, add 6, but that doesn't work there. So let me go back here. And I could do, well, 3 times 3 equals 9, so that was squared. So I did 3 squared, right? And here, oh, look at that. I can square that. 6 times 6 is 36. And then I've got 9 times 9 is 81, so 9 squared. So what I did was I squared here. 1 times 1 is 1. I squared x here. So 3 times 3 is 9. I squared x here. 6 times 6 is 36. And I squared x here. 9 times 9 is 81. So what I did was I took my x value and I squared it. So my function rule is x squared. And that's your answer right there. Okay, let's go ahead and try another one. Okay, so here's the next one. So let's go ahead and make our table again. We'll put our x's here and our y's here. And we went from 1 to -1. We went from 2 to 0. We went from 3 to 1 and 4 to 2. Okay, now here's a little trick. Anytime you have 0 in the y or the x value, makes it a little bit easier. So what I do is I look, well, how did it get from 0 to whatever? So I went from 2 to 0, so obviously I subtracted 2. So I'm just going to see if I subtract 2 from everything, if it works. So if I subtract 2 from here, definitely works. If I subtract 2 from here, that works. And if I subtract 2 from there, that works. So if I plug these in and I do 1 minus 2, 1 for the x value, minus 2. If I do 2 for the x and then minus 2, I definitely get 0. If I do 3 for x and then minus 2, I get 1. And if I do 4 for the x and minus 2, I get 2. So my rule is going to be x for these values right here, minus 2. So I've got f of x is x minus 2. And that's our rule right there. Okay, let's do the next one. Oh, here we go with the relation, okay? So we have to, first of all, we're going to have to make our table. And then we're going to go ahead and fill in our x values and our y values. So we had a -1 and a -8. And we had a 0 and a -7. Love those zeros. And we had 1 and a -6. And we had 2 and -5. All right, so let's go to the 0. How did I get from 0 to -7? Well, obviously I subtracted 7. Can I do that with the rest? Can I go from -1 to -8 by subtracting 7? Absolutely. Can I go from +1 to -6 by subtracting 7? Absolutely. Can I go from 2 to -5 by subtracting 7? Yes. So let's put that in as our rule. So if I take my x as -1 and I subtract 7, I'm going to get -8. If I take x as 0 and I subtract 7, I get -7. If I take x as a +1 and subtract 7, I'm going to get a -6. If I take an x as a +2 and I subtract 7, I'm going to get a -5. So my rule is going to be x minus 7. So I have f of x is x minus 7, and that is my rule right there. Okay, we have one more, and we have another relation, so let's go ahead and make our table. And we put our x values here, sorry, and our y values there. And we're going to go ahead and plug them in. So I have a -2 goes to a 3. And I have a -1 that goes to a +4. And then I have a 0 that goes to a +5. And I have a 1 that goes to a 6. Okay, I have that 0 again, so let's go ahead and use it. I went from 0 to +5, so that was +5. Can I do that with the rest? If I add 5 to 1, do I get 6? Yes. If I add 5 to -1, do I get 4? Yes. If I add 5 to -2, do I get 3? Yes. Yay. That was so easy. Okay, so if I do -2 for x and I add 5, I get 3. If I do -1 for x and add 5, I get 4. If I do 0 for x and add 5, I get 5. If I do 1 for x and add, 5, I get 6. So my rule is going to be x. I have all the x's there, and I add 5 to it. So my rule is going to be f of x is x plus 5. And that is how you write a function rule. So if you have any questions, please make sure that you come to class with them. Also make sure that all of these practice problems that we did are in your practice problem boxes. There are a few, so you should be able to fill up at least 3 of your boxes. So go ahead and do that, and make sure you have your questions ready. Have a great day.